Hi guys, so I'm back for another video, and for today's video I'm going to talk to you to tackle about chapter 11, build a small network summary. So network design has devices in a small network application and protocols, and scale to larger networks. Devices in a small network includes small network topologies, device selection for a small network, IP addressing for a small networking, redundancy in a small network, and traffic management. Small network topologies. The majority of businesses are small. It is not surprising then that the majority of networks are also small. A typical small business network is business network. With small networks, the design of the network is usually simple. Device selection for a small network. In order to meet user requirements, even small networks require planning and design. Planning ensures that all requirements, cost factors, and deployment options are given due consideration. IP addressing for a small network. When implementing a small network, it is necessary to plan the IP addressing space. Redundancy in a small network. Another important part of network design is reliability. Even small businesses often rely heavily on their network for business operation. Traffic management. The network administrator should consider the various types of traffic and their treatment in the network design. The routers and switches in a small network should be configured to support real-time traffic, such as voice and video, in a distinct manner relative to other data traffic. Next, small network applications and protocols. It includes common applications, common protocols, voice and video applications. So common applications. The network is only as useful as the application that are on it. There are two forms of software programs or processes that provide access to the network: the network applications and application layer services. Common protocols. Most of a technician's work in either a small or a large network will in some way be involved with network protocols. Voice and video applications. Businesses today are increasingly using IP telephony and streaming media to communicate with customers and business partners. The network administrator must ensure the proper equipment is installed in the network and that the network devices are configured to ensure priority delivery. Next is scale to larger networks. So small network growth. Growth is a natural process for many small businesses, and their networks must grow accordingly. Protocol analysis. When trying to determine how to manage network traffic, especially as the network grows, it is important to understand the type of traffic that is crossing the network as well as the current traffic flow. Employee network utilization. In addition to understanding changing traffic trends, a network administrator must also be aware of how network use is changing. Next is network security. The security threats and vulnerabilities, network attacks, network attack mitigation, and device security. So first is security threats and vulnerabilities. It includes types of threats, physical security, and types of vulnerabilities. So first is types of threats. Whether wired or wireless, computer networks are essential to everyday activities. Individuals and organizations alike depend on their computers and networks. Intrusion by an unauthorized person can result in costly network outages and loss of work. Physical security. An equally important vulnerability is the physical security of devices. An attacker can deny the use of network resources if those resources can be physically compromised. The four classes of physical threats are hardware threats, environmental threats, electrical threats, and maintenance threats. In hardware threats, It is a physical damage to servers, routers, switches, cabling plant, and workstations. Then the environmental threats. It is the temperature extremes, or too hot or too cold, or humidity extremes, or too wet or too dry. Then electrical threats is the voltage spikes, insufficient supply voltage or brownouts, and unconditioned power or noise, and total power loss. Then last is maintenance threats. Poor handling of key electrical components or electrostatic discharge, lack of critical spare parts, poor cabling, and poor labeling. Next is types of vulnerabilities. Vulnerability is a degree of weakness which is inherent in every network and device. Next, network attacks. Types of malware, reconnaissance attacks, access attacks, and denial of service attacks. So the types of malware or malicious code or malcode is short for malicious software. It is code or software that is specifically designed to damage, disrupt, steal, or inflict bad or illegitimate action on data, hosts, or networks. Viruses, worms, and Trojan horses are types of malware. Reconnaissance attacks. In addition to malicious code attacks, it is also possible for network to fall prey to various network attacks. Network attacks can be classified into three major categories. First is reconnaissance attacks, discovery and mapping of system services or vulnerabilities. Second is access attacks, the unauthorized manipulation of data, system access, or user privileges. And last is denial of service, the disabling or corruption of network systems or services. Next is access attacks. Access attacks exploit known vulnerabilities in authentication services, FTP services, and web services to gain entry to web accounts, confidential databases, and other sensitive information. Next is denial of service attacks. Denial of service attack or DOS attacks are the most publicized form of attack and also among the most difficult to eliminate. The network attack mitigation includes backup, upgrade, update, and patch, authentication, authorization, and accounting, firewalls, and endpoint security. So backup, update, and patch. Keeping up to date with the latest developments can lead to a more effective defense against network attacks. As new malware is released, enterprises need to keep current the latest versions of antivirus software. Next is authentication, authorization, and accounting. So authentication, authorization, and accounting are AAA. Network security services provide the primary framework to set up access control on a network device. The AAA is a way to control who is permitted to access a network or authenticate, what they can do while they are there or authorized, and what actions they perform while accessing the network or accounting. Next is firewalls. A firewall is one of the most effective security tools available for protecting users from external threats. Network firewalls reside between two or more networks, control the traffic between them, and help prevent unauthorized access. Last in this slide is endpoint security. An endpoint or host is an individual computer system or device that acts as a network client. Common endpoints are laptops, desktops, servers, smartphones, and tablets. Next, device security. Device security overview is when a new operating system is installed on a device. The security settings are set to the default values. In most cases, this level of security is inadequate. Passwords. To protect the network devices, it is important to use strong passwords. Basic security practices. Strong passwords are only as useful as they are secret There are several steps that can be taken to help ensure that passwords remain secret. Using the global configuration command, service password encryption prevents unauthorized individuals from viewing passwords in plain text in the configuration file. Next is enable SSH. Telnet is not secure. Data contained within a Telnet packet is transmitted and encrypted. It is highly recommended to enable SSH on devices for secure remote access. It is possible to configure a Cisco device to support SSH using 4 steps. Next is basic network performance. The ping command, the tracer root, and tracer command, show commands, host and iOS commands, and debugging. The ping command, interpreting ping results, extended ping, and network baseline. Interpreting ping results using the ping command is an effective way to test connectivity. The ping command uses the Internet Control Message Protocol or ICMP and verifies layer 3 connectivity. Extended ping. The Cisco iOS offers an extended mode of the ping command. This mode is entered by typing ping in privileged exec mode without a destination IP address. Network baseline. One of the most effective tools for monitoring and troubleshooting network performance is to establish a network baseline. The tracer root and tracer command. Interpreting trace messages. A tracer turns a list of hops as a packet is routed through a network. The form of the command depends on where the command is issued. Extended tracer root. Designed as a variation of the tracer root command, the extended trace root command allows the administrator to adjust parameters related to the command operation. The show commands. Common show commands revisited. The Cisco iOS CLI show commands display relevant information about the configuration and operation of the device. Host and iOS commands. The ipconfig command. The IP address of the default gateway of a host can be viewed by issuing the ipconfig command at the command line of a Windows computer. The ARP command. The ARP command is executed from the Windows command prompt. The ARP-A command lists all devices currently in the ARP cache of the host. Then, the show IP interface command. There are several other iOS commands that are useful. The Cisco, for example, is the Cisco Discovery Protocol or CDP. It's a Cisco proprietary protocol that runs at the data link layer. Next is debugging. The debug command and the terminal monitor command. The debug command. iOS processes, protocols, mechanisms, and events generate messages to communicate their status. The terminal monitor command. Connections to grant access to the iOS command line interface can be established locally or remotely. Next is network troubleshooting. Troubleshooting methodologies, troubleshoot cables and interfaces, troubleshooting scenarios. Troubleshooting methodologies. Basic troubleshooting approaches. Network problems can be simple or complex and can result from a combination of hardware, software, and connectivity issues. Resolve or escalate. In some situations, it may not be possible to resolve the problem immediately. A problem should be escalated when it requires a manager's decision, some specific expertise, or network access level and available to the troubleshooting technician. Verify and monitor solution. Cisco iOS includes powerful tools with help troubleshooting and verification. Next is troubleshoot cables and interfaces. A duplex operation. In data communications, duplex refers to the direction of data transmission between two devices. Duplex mismatch. Duplex mismatches may be difficult to troubleshoot as the communication between devices still occurs. Troubleshooting scenarios. IP addressing issues on iOS device. IP address related problems will likely keep remote network devices from communicating. Because IP addresses are hierarchical, any IP addresses assigned to a network device must conform to the network range of addresses. IP addressing issues on end device. Default gateway issues. A default gateway for an end device is the closest networking device that can forward traffic to other networks. Then last is troubleshooting DNS issues. Domain name service or DNS defines an authorized an automated service that matches names such as www.cisco.com with the IP address. While DNS resolution is not crucial to device communication, it is very important to the end user. Okay, that's all for today. Thank you.